problems show that there really isn't a substitute for visualizing what you're integrating over, unfortunately. Alright. Now, number 5, see there's this constant a in there. I meant to fill in a specific value, I just forgot. So, it's perfectly fine if you just want to set a equal 1. It doesn't really matter. So we have minus root 2 over 2 to 0, minus x to square root of 8, 1 minus x squared, x squared, y squared, dy dx. Right. So this is one where it really is helpful to try to visualize the region. So since you already know that this is a polar coordinates problem, it will be helpful to keep in mind a circle, just for reference. So we already have this value of minus square root of 2 over 2 here, y being up going to the square root of 1 minus x squared. So this suggests you're dealing with a circle of radius a, or radius 1 in this case. So we take well really it's a 135 degree angle here. From this x value, this is minus square root of 2 over 2. So your region starts here and ends here at x equals 0. But then your y values, so your y value, it starts at minus x. Now here we're only dealing with negative x. So minus x is going to be positive. So for each x between minus square root of 2 over 2 and 0, you're going to pick the corresponding negated value to be your y. And this is a line, y equals minus x. So this marks the bottom boundary of your region. And then the top boundary, well, this is a curve y equals square root of 1 minus x squared. So this is the top boundary. So it's this pie slice is the region. So for polar coordinates, you want to ask yourself, what angles theta does this region include? And which are points that are what distances away from the origin? Because out here we have a circle of radius 1, so that's all the points r equals 1. So which r is included, which theta is included, and that will tell you what your limits are. So people there thought that number 6 was kind of a doozy.
Yeah, this is the one that's like 10, I think.
Also will warm up to the bonus question. Okay.
Yeah, that's what it is. And bonus question.
Okay, and we have a tetrahedron. Okay, so vertices 2, 0. Oh wait, not there. 0, 2, 0, 1, 0, 0, 4, 1, 0. So here we have a base of a tetrahedron. We have one more vertex. That's 1 unit up from this vertex. So this is the solid that you're integrating over, drawn in the XYZ plane space. And now we'll also look at it from above. This is the XY plane. Let's see, where the fourth vertex is sitting on top of this vertex. Alright, so this is kind of like number 4. How do you get the limits? So you have some flexibility here because it's relatively nice shape. You don't have curved surfaces and so forth. So you can pick your limits in terms of x. You can do x first, or you can do y first, whichever is more convenient. And then the base of its tetrahedron, that's simple enough, z equals 0. But then you have to get the plane that defines the top of the tetrahedron, and that's where the hint comes in. Because what you really have is the top of a tetrahedron is a portion of a plane, and that's going to be your upper limit in z. So how do you get the equation of a plane given 3 points? Especially the 2 of you who saw this last semester.
Find the cross product.
Cross product of what though? So we just have 3 points.
Is that the cross product of the magnitude?
No.
Wrong direction. Does that have to do with the matrix?
Well, you couldn't carry out the cross product that way, but right now we're focusing on what exactly is it? Do you take the cross product of?
3 points and
Yeah, so what information can you need to get from those 3 points? So you can use a cross product. Nicole not ringing a bell either?
I'm reading summers in here about moments in the center of mass with a problem like this, but
No, this is purely last semester stuff. No, you define vectors between any 2 pairs of points. So vector u, vector v, doesn't matter which pairs you choose. So then the normal to the plane is u cross v. So that would have components a, b, and c.